Hi everyone, I am Meshiell Pablo and I am teaching grade 9 mathematics. Today I will be teaching you rational exponents. In other books, that is fractional exponents, since the exponent contains fractions. After this video, you are expected to write expressions with rational exponents as radicals, simplify expressions with rational exponents, understand the relationship between radicals and exponents and their concepts, and apply the importance of rational exponents in the real world. Before we proceed to the main topic, let us have a short recall on the simplifying positive exponents, because this is very essential to our next topic. Who am I? To answer this question, we are going to decode by matching column A with column B. So, for example, here in number 1, we have 2 raised to 4. So, 2 there is the base and 4 is the exponent. So, we are going to multiply 2 by 4 times. So, 2 times 2 is 4 times 2, 8 times 2 again is 16. So, we are going to look for the answer in column B. So, 16 is located at letter A. And we will write number 1, as letter A here. Next, number 2. So, 3 raised to 3 means 3 times 3 times 3, which is equal to 27, and that is letter D. So, number 2 is letter D. Next, for number 3, we have 2 raised to 5. So, 2 times 2 times 2 times 2 times 2 again is 32. So, that is 32, and that is letter C for number 3. Number 4, we have 4 raised to 3. 4 times 4 is 16. Times 4 again, so that's 64. So, that is letter R. Okay, so we will write number 4 as letter R. So, we have 2 4s here. Next, number 5, 3 raised to 4 means 3 times 3, 9 times 3, 27 times 3 again is 81. So, that is letter E. Number 5 is letter E. So, if you notice, there are 4 5s here. So, we will write all by letter E. Okay, keep going. Another 5 here. Okay, last one, we have E on number 5. Next, number 6. So, we have 7 raised to 3 means 7 times 7 is 49. Times 7 again is 343. And that is, letter N. So, we will write N above number 6. Okay. So, the first name is already complete. That is Rene. So, you have a clue already. Next, number 7. 5 raised to 3. 5 raised to 3 means 5 times 5 times 5, which is 125, and that is letter S. Okay, so number 7, letter S. We have 2 7s here. Last one, number 8. 10 raised to 3 means 10 times 10 is 100, times 10 again is 1000, so T. So, who am I? That is Rene Descartes. Rene Descartes. Why is it pronounced as Descartes instead of Descartes? So that is a French name. So that is why that is called Rene Descartes. He invented the Cartesian coordinate system, developed analytic geometry, and laid the foundation for the development of calculus. He also did groundbreaking work in physics, most prominently in the field of optics. Okay, let's have a recall on a couple of things here. So, if you notice, in number 1, that is a positive exponent, just like we did earlier, a second ago. Okay, so 5 raised to 2 means 5 times 5. We know this already, that this is 25. Okay, next. So, if you notice, next example here is the exponent is negative. So, what will we do? So, this is the negative exponent. We learned that if the exponent is negative, we're going to write 1 in the numerator and drop the number, provided the exponent now will become positive. Okay? Then let us simplify. So we're going to write 1 here over 5 raised to 2, so that is 25. Okay? Next. So if you notice in the next one, we have the negative or the zero exponent. So in the zero exponent, by definition, any number raised to zero, the answer is 1. Let's go a little bit beyond. Okay, what about if the exponent is a fraction? Okay, so what will we do? Okay, so this is different from the previous example. The exponent now is a fraction. So b raised to 1/2 can be rewrite, or you can rewrite this in as square root of b. Okay, similarly with b raised to 1/3 is also rewrite this by the cube root of b. Likewise, b raised to 1/4 is also the fourth root of b. So these two things are interchangeable. If this is the case, okay, so if this is the case, this is actually true. So we simply take b raised to 1/2 is equal to square root of b by squaring both sides. Why is it squaring both sides? Why I need to square it by 2? Okay, since the exponent of b is 1/2, okay, our purpose there to make the exponent of b equals to 1. So what will you multiply to 1/2 to make it 1? So of course, we're going to multiply this reciprocal of 1/2, which is 2. Okay, so b now will become, or b raised to 1/2 raised to 2 again is b raised to 1, because we are going to cancel this one. Okay, so we knew already that b raised to 1 is also b. So this is equal to, okay, we're going to work on the other side of the equation. We are going to multiply or raise this also to the exponent 2, or the power of 2. Why? Why we are going to raise to the exponent 2? Okay, to make the equation balance. So we knew already that there is an index 2 here. So we can cancel out 2, the exponent 2 and the index 2. And what is left is b. So b is equal to b. Next, so b raised to 1/3. Again, the exponent is 1/3. Okay, what will you multiply to 1/3 to make 1? Okay, of course, the reciprocal of 1/3 is 3. Okay, so we are going to cancel this out. So b is equal to 1. And we knew that b raised to 1 is also b. Okay, on the right side of the equation, so we have, okay, again, since we raised the exponent 3 on the left side of the equation, we also do in the right side of the equation. Okay, to make the equation balance. Again, we're going to cancel this out. And what is left is b. And now b is equal to b. Okay, last one. b raised to 1/4. So this is, the exponent is 1/4. The reciprocal of 1/4 is 4. Okay, so we cancel this out. What is left is b raised to 1. And b raised to 1 is equal to b. So the right side of the equation, we are going to raise the exponent by 4. Or raise the expression by 4. Okay, so we cancel this out. What is left is b. And b is equal to b. So b is equal to b. That is the identity that b is equal to b. Okay, so when you see a fraction in an exponent, it is also the same as radicals. So it's just like you have water and ice. They are both H2O, but they are in different representation of the same thing. So if you see an exponent 1/2, okay, that is a square root. If you see an exponent 1/3, that is a cube root. When you see an exponent 1/4, that is the fourth root, and so on and so forth. So can you see? Okay, the pattern is not hard to understand. Okay, so let's go beyond a little bit further. So this time, the exponent is not 1/3 or 1/2 or 1/4, but that is already 2/3. So the numerator is not 1. Okay, so what will we do here? So how can I write this in radical form? So you may rewrite this, okay, as power of a power. So when you see an exponent raised to another exponent, so you just simply multiply. So for example here, okay, we're going to reduce this by b. You can write this as b squared quantity raised to 1/3. Why? Because again, this is power or the exponent raised to another exponent. Okay, so based on the law of exponent, we just simply multiply the exponent. So when you multiply 2 by 1/3, you will get the same thing, which is 2/3. Did you get? Next, so how are you going to write this in radical form? So b raised to 2, quantity raised to 1/3 is also the same as, okay, b squared or the cube root of b squared. However, I can also write this in another way. How? Okay, so we can also write this as b raised to 1/3 quantity raised to 2. So in radical form, you may write this as the cube root of b, okay, quantity raised to 2. Okay, so it is the representation that of the same thing, there is no difference at all. Okay, so you don't need to memorize. That is, you just simply understand the fundamental rule. Okay, so we're going to summarize what we did earlier. Okay, so rational exponents are exponents in the form b raised to m over n, where m and n are both integers and n must not be equal to 0. Why? If n will become 0, that is already undefined. So n must not be equal to 0. Okay, we have also discussed that b raised to 1 over n, let's say b raised to 1/2, you can rewrite this in radical form as the nth root of b. And the last example, we have b raised to m over n, let's say 2/3. Okay, so you can rewrite this either the nth root of b raised to m or the nth root of b quantity raised to m. What if we have 81 raised to 1/2? Okay, so what will we do if the coefficient now is not a variable, that is already a constant, okay, a number. So what will we do in this case? So we knew that raised to 1/2, that is a square root, okay, square root of 81. So square root of 81 is equal to 9. Okay, to verify, you may grab a calculator. Okay, then press 81 raised to 0.5, since we knew that 0.5 is equivalent to 1/2. So you will get the same thing. Next, so this one we have a negative exponent. So 49 raised to 1/2 or negative 1/2. Okay, so again, this is a negative exponent. We will write 1 in the numerator. And then, okay, so we will write the solution here. So we have 1 over 49 raised to negative 1/2. So we will drop the number and the exponent now will become positive. Positive 1/2. Okay, so to simplify, okay, we will write 1. And then, so we knew that 49 raised to 1/2 is square root of 49, right? Okay, square root of 49. And square root of 49 is equal to 7. So we have 1 over 7. So this is the answer. Okay, so this is just a pretty elementary. So let's do something challenging. Okay, so we have 27 raised to 2/3. So we do this, or we have this, we learned a second ago that we can do this in different ways. Okay, so you can do the power first, then square it, or you can square it then do the power. So my advice is you just pick one. Okay, but I'm gonna do both to show you what will happen. Okay, so this is, okay, just copy the base 27. Okay, so I will square this first and then raise to an exponent 1/3. Okay, so this will be in radical form. You can express this as the cube root of 27 squared. Okay, so we are going to simplify first what is inside the cube root. So that is 27 squared is, what is 27 squared? So that is, you may grab your calculator. So I think that is 700. Okay, so again, 27 raised to 2 is 729. Okay, so we can grab a calculator to verify that. Okay, so it's a big number, right? But then, what is the cube root of 727? This is the difficult one. Okay, so if you are not a mathematician, or if you are not good in math, you will find difficulty in this. But okay, so 729, you can factor this as 9 times 81. Okay, so we have 9 times 81. So we do the factor tree to show you that, okay, there are factors. What number, when you multiply by 3 times the answer, the same number when you multiply 3 times the answer is 729. So that is, using the factor 3, I got 9. Because 9 times 9 is 81, times 9 again is 729. So the answer here is 9. Okay, 9. Another method, okay, I will do the different way. Okay, so we have 27. Okay, if you can still remember a while ago, I show you the two different ways. You can square it, then raise to the exponent, which is a fraction, or a fraction and then an exponent to, or a whole number. Okay, so what I do first is raise to the fraction exponent, which is fraction, which is 1/3. Okay, raise to 2, because 1/3 times 2 is the same thing as 2/3. So the value is the same, nothing's changed. Okay, now I will do the radical form, or convert this into radical form. So this is the cube root. I will do first the 27 raised to 1/3, so that is the cube root of 27. And then I square this. Okay, next, so I am going to simplify first things inside the, or the numbers inside the parentheses. So what is the cube root of 27? As we discussed in the recall, so the cube root of 27 is 3. Okay, so we will write 3 here, and then do the exponent 2, or raise to the exponent 2. So 3 squared is the same as 9. So, do we get the same answer? Yes, they are the same. Okay, so we all knew that the square, okay, So if you have a choice, just make a root first so that you don't have any difficulties here. Just like we did here, I grab just what I did is I post, since I have to press the calculator, 27 squared, which is I got 729. So but if you want, or if you have a choice, you can do the square root first. Okay, next, what about 16 raised to 3/4? So 16 raised to 3/4. Again, since we have encountered already, which one are you going to use? The first one, the first solution, or the second solution? So my advice, take the second one. So first here, we're going to factor this first. So we have 16 raised to, since the denominator is 4, so 1/4. Okay, and then we're going to raise this to the exponent of the power of 3, another power of 3. Since 1/4 times 3 is the same as 3/4. Okay, so again, they are the same thing. Okay, nothing changed. Okay, next, so we're going to convert this into radical form. So this is the 4th root of 16. Okay, quantity raised to 3 to the power of 3. Okay, next, so we're going to simplify 16. What number when you multiply by 4 times? Why is it 4 times? Since the index or the number outside the radical sign is 4. So we are going to think of a number, the same number, when you multiply by 4 times, the answer is 16. So we have 2 times 2 times 2. So what we call this is a factor 3. Okay, factor 3, as we learned during elementaries, I think grade 4 or grade 5. Okay, so are you familiar? Can you still remember? Okay, so again, the 16th root of 4 is 2. And then we're going to enclose this into parentheses and raise to the power of 3. So 2 raised to 3 is equal to 8. Okay, so the answer is 8. Again, you can verify using your calculator. Next, so what if we have a negative number here and our exponent is negative also? Okay, so we all knew that. Okay, so notice that everything inside the parentheses is raised to the power of negative 3. And negative 3 applies to the whole thing. Okay, so what does it mean? So this negative 1/3, which is the exponent, this applies to the whole thing here inside the parentheses. So let's say, for example, so we're going to change this into the radical form. Okay, or convert or rewrite. So we have, okay, are we going to include negative, are we going to include the negative sign? Yes. Why? Because that is the negative sign included inside the parentheses. So we have the square root, or the, so, okay, sorry, but before that, we're going to, I forgot, so we're going to change this first. Okay, or we're going to simplify first using the fractional exponent, positive exponent. Okay, before we do something in radical. Okay, so this is, since the exponent is negative, we will write 1 in the numerator, and then we will drop the number negative 125, quantity raised to 1/3, positive. This is already positive. Okay, next, before we write this into radical form, so we have 1 over, okay, the cube root. Can you follow? Okay, the cube root of negative 125. Okay, next. So, we're going to think of a number, that same number, when you multiply by 3 times, the answer is negative 125. So, the numbers, what are the numbers? Okay, using the factor 3. So, we have, since that is negative and the index is an odd number, so, the factors will be negative. So, we have negative 5. Okay, negative 5. Because negative 5 times negative 5 is positive 25. And positive 25 times negative 5 is negative 125. So, that's why our factor is negative 5. So, the answer here, so we have, okay, equals to 1 over negative 5. 1 over negative 5. Or you may also write this as, okay, you can put the negative sign, okay, here. Okay, so whichever, okay, you can write the first one or the second one. So they are all correct. Next, what if 4 raised to negative 0.5? So again, we are going to rewrite 0.5 or 0.5 by a fraction form. Okay, so this is 4 raised to negative 1/2. Okay. Next, since the exponent is negative again, by negative exponent, we write 1 as numerator, drop the number, including the exponent, provided the exponent now will become positive. Okay, so we have 1 over, okay, the square root of 4. Okay, so without doing the factor 3, we knew already, since that is very easy, we knew already that 4 square root of 4 is equal to 2. So, 4 raised to negative 0.5 is equal to 1/2. Okay, let's proceed. Okay, so what have you noticed in this example? Okay, there is no parenthesis yet. Okay, there is no parenthesis already. So how do we simplify this? So the exponents does not apply to negative because there is no parenthesis grouping together. Okay, so unlike in the previous example in negative 25 raised to negative 1/3, so the negative sign is under, or that is negative 1/3, which is the exponent, applies to negative 125. But in this case, since there is no grouping symbol here, or there is no parenthesis, so then the exponent 2/3 does not apply to a negative sign. Okay, so we have negative 8. Okay, so quantity raised to 1/3. Okay, quantity squared. Okay, so have you noticed that the negative sign is outside the parenthesis? Again, that is the exponent 2/3 does not apply to negative. Okay, next we're going to convert this into radical form. So this will be now the negative, okay, a cube root of 8, quantity raised to 2. So this is equal to negative. Okay, so think of a number that when you multiply by 3 times, the answer is 8. So that is 2 times 2 times 2. So the answer is 2. Okay, enclose this in parentheses, then raise to the power of 2. So what is 2 raised to 2? So that is 4. So the answer here is negative 4. Okay, so the practice exercises, I will give this as your assignment to be submitted during the retrieval of the answer sheets. Okay, so please copy and show the solution. You may write your answer in the intermediate pad. Okay, so we have to wrap up. We have to summarize what we have learned. As you noticed, I gave this already earlier. But I will ask you to do not memorize, but to familiarize and understand the fundamental rule. okay, of these concepts. Okay, so for the application, I have here an example. How do you apply rational exponents in your daily life or in the real world? Okay, so for example, the financial industry uses rational exponents to compute interest, the depreciation, and inflation in areas like home buying. Another example is the rapid increase of the COVID-19 patients all over the world. Okay, so you may apply also that. Okay, another assignment, I will assign you to state or give two, at least two examples or some applications of real life, examples of rational exponents in real life. So, and the last assignment, so supposedly this is an evaluation since you're not here, so I will assign this as your assignment again to be submitted during the retrieval of the answer sheets. So please copy, show the solution, okay? And then if you have some questions, okay, you may send me a personal message, okay, to us or so for some verification. Okay, I think we stopped here. Thank you for listening. Thank you for your time. Okay, God bless. Bye. Bye-bye.